Hello everyone. So now we are going to take this question. All nodes distance k in binary tree. Okay, I have put effort around 15 to 20 minutes to try to think over this. So okay, let me go through you about my introspection. Okay, so let's first read the question. We are given a binary tree with root node and target node and an integer value k. So there's a root node. This is a given binary tree. Let's make it big a bit. I will tell you why I'm making it big. So we have created our binary tree. Now what we have to do is take a target node. Okay. So let us suppose this is our target node. Now return all the nodes which are at distance k from it. The question is this: travel k edges from this target. So that 1, 2, 3. Let's say k is equal to 3. Okay. So this is our target. From here we can travel 1, 2, 3. This 1, 2, 3. This one also. 1, 2. Okay, let's create more edges. Magenta, yeah, something like this. So 1, 2, 3. This will be also considered. This will be also considered. Now 1, 2, and 3. Okay. So what if there's one more, like something like this? Let's take my magenta again. So there's something like this, a node, or one more node. So this will be also taken. So what we can observe here is we have from target we have to go k nodes everywhere. Like it's not like there is only one or two layer solution exists in many layers. Okay, and we have to find it. So okay, so to solve, and one more thing, from target down below we need only the kth layer. Okay, or say suppose the target layer is t, so we need k, so we need k plus tth layer, something like that. Okay, and for above, what, just see what is happening. We are going to the ancestor, one of the ancestor, or here it is parent. From here we are traversing 1 and 2. So 2 is equal to what? K minus 1. Okay, this is 1, then this is 2, and this is equal to k minus 1. Let's check what's happening here. Why are we taking this? So let's go to one of the more ancestor. This will be 1, 2, and from here we are going 1. Okay, 1 down from this ancestor. Okay, sorry. Now this is 2, so k minus 2 equals 1, and that's why we are using 1 here. Okay, one more thing we have to check it. When we are at any parent, we don't have to go back, in, like we don't have to go left side, we have to go further, so we can use a visited array to solve this. So it is not that intuitive. We will take like 15-20 minutes or to think, to click it, to click what should be done and how to be done, and I have already given that. So I think it's clear. So let's directly jump to solve it. Okay, to write code. Okay, it is gonna be a bit interesting. So what we will do, we will find our target node is already given, so we don't need to find our target node. Instead, we have to find all the parents of target node. Like this is target node, we have to store this and everything. So let's do a DFS. Okay, and we have our root node, then target node, and result, something like, not result, parents. Okay, so initially parents is empty. Now what we are gonna do, we will call DFS on root.left. Okay, passing target and parents. The same thing we are gonna do on right node, I mean in the right subtree. Rather, it would be better to say it in the right subtree. So yeah, and before this, if not root, then return. Okay, and one more thing, if root is equal to target, root is equal to target. If both of them are same, then just return parents. Okay, and every time like we are going to left, then append root dot left, and this will gonna pass the copy inside it. So parents plus, it will be parents plus root dot left and its copy. So we don't have to worry much about it. And here root dot right, and finally return parents. So parents will become DFS of root comma target comma parents. Okay, sorry, parents is already provided, so let's stick with root and target. Let's print parents and see. Okay, so instead for I in parents, print I dot val. Okay, so this is one of the input. We can visualize it and also find our way. Okay. So it is already provided. Let's run code. None type. Okay, parents is none. For DFS of root comma target. Oh, sorry, return. No, no, no. We can't do this. Okay, rather we are gonna use return. Okay, and we'll give this parents inside or outside of it. This is like this. If root is equal to target, then parents is equal to, not parents, parent global, something like this. Then parent global will become the parents. Okay, let's see. Sorry, y is equal to doesn't work always. So the next thing we are going to do is after find. Hey, none type object is not iterable. Sorry, parents instead of parents. I'm gonna only call DFS and here parent global. Check it whether it is working fine or not. Output is null. Output is null, but should have printed something. Like print parent global. Parent global is equal to parents. Okay. Sorry, we have to take a copy of it here also. I guess. Not working now. Target is a tree node, okay? With parents, do we have to pass its copy to? Like I never used copy inside it. Okay, let's try. Because we are already appending both of them, not appending, like adding. So it will already make the copy. If not root return, if root is equal to target, return directly return, and parent global, make parent global equals to parents. It will go to for DFS only once. Print root dot val. Let's try this also to understand what's going on inside. Okay. So parent is updated. Parents is updated like 3510, and then it will become null at a point. Yeah, if not root, return. And if root is equal to target, then parent global will become parents, then return. I'm not seeing any flaw. One second. Parents dot copy. Okay. This is target. Go to left. Go to right. Let's print it also. Print. So there was one. Okay. Print root is root dot val, comma root dot target. Sorry, root dot target. Sorry, target dot val. So it is printing something. Target dot val. Okay. 5 and 5 is printed. Yeah. It should have updated parent global. If these both 5 are pending, it's the value is coming from here. Print parents here. So there should be 3 values, and at a point parent should become null. That's why it is resulting into null. So no, this is what? 3 comma null. Okay, 3 comma null. Let's remove other print statements. Okay, and finally print parent global. Yeah, so we have this 5 6. We have this. Yeah, we have it in parents. 5 6. Okay, no, I can't see it. But it is, yeah, and after that it is why it is null. Okay, this parent global is null. Parent global spelling is also correct. So once you find it, then break it. Something like this I have to put. If root is equal to target, let's take a flag. Something like flag is false or true. If flag and root is equal to target, then flag is equal to false. And we here I'm gonna put non-local flag. It's lame, but okay. I don't know why it is working bad here. Again, like I have, this is the value now. So I dot val. I'm traversing. Okay. So parents is good, but when I have updated, something else is going on. Okay. DFS root comma target. Parents is initially like this. Root dot left. I'm appending root dot left and root dot right. And calling the okay. Sorry. I have to append root now because I have passed through root. Mistake. Took more than 5 minutes to. Still not working. So initially parents is equal to, or rather I have to say parents is equal to root initially. Will root work? Let's see. And parent should be empty. Okay, and every time we are passing a copy of parents plus root dot left. No, no, instead root. We are calling it on left, we are calling it on right. We are passing our parents dot copy. Why it is not working? Okay, let's print Pikachu. It will help us. Typo in your name. 1 second. We must be going inside Pikachu once. Okay, cool. And still we are not able to update our parent global. Okay, so let's make it non-local inside. We should be able to make our parent global equals parents of starting to end. Okay, so now, yeah, after using non-local, it is giving output. I don't know, but without non-local, array should be read inside. So for I in parent global, print I dot val is not working now. How is it? No, it is not working. Only 3 is printed, rest are not. Okay. So for I in parent global, print I. Rather, I have to use it. Okay, okay. Why I dot val is not working? 1 second. Let's check our output. So this is our output. Okay. Um, let's take it. So we have one tree node and we have another tree node. Yeah, answer should be this. Like after 3, the 5 is there. Okay, no problem. Everything's fine. So 3 is appended and it's our parent. So let's convert our target to 4. Okay, it will better visualize us. So let's check. Yeah, this is our target now. Okay, if this is target, then we are starting from 3. Okay, it is printing from first, so we have to reverse it and check it. So 3 is included. Then the next thing included is, okay, this is here, dictionary. Yeah, tree node 3. It should print val also now. Print I dot val. It would give us better understanding. It is giving us 4. 4, yeah. So 3, 5, and 2, yeah. We have to take it in reverse. Okay, so we have now our parents stored inside parent global. Okay. Now next thing we have to do is we have to start, yeah, we have to traverse the parent. Okay. And we also have to find the level of target node. From here, take all this as solution, and for every parent, okay, from starting from this. If go to left and go to right also. So if left is visited, okay, mark target as visited, and the parent we are taking is, yeah, okay, it will work. So every time we are making, it's like a BFS call. So on every parent, but the left is already visited, so we will go to right. Or let's let's say every other parents are visited, so we are going to right, and every time we are going to right for of k minus 1. Okay, let's check this out. So we need a BFS traversal to solve this. So let's create a BFS function too. Let's create it here. Yeah, define BFS root. Okay, we will give you. We will provide root. Okay, we can do one more thing in here. We can find the level of target directly from the DFS call. So let's pass something like level is equal to 0. Okay, initially, and every time we are increasing, okay, not here, yeah, we can pass initially level is equal to 0, and every time we are increasing level plus 1, because we are going down here, level plus 1. Okay, and yeah, so both are called. Now what we will do, level of target, let's create a variable level of target is equal to initially minus 1. Okay, now if this is correct, then level of target, make level of target as level. Okay, and use this level of target as non-local variable inside the function, the helper function. Okay, now we have our level of target. So let's print our level of target too, whether it is working fine or not. Sorry. BFS, okay. So, give 1 second. So it's now yeah. So we have our, yeah, this is level of target. Okay. Now let's move to create our BFS function. So BFS will take a root. BFS, okay. BFS is gonna return. BFS is gonna also take one more thing, visited. Okay. And the level, and return all the nodes at this level. Yeah, it is going to return all the nodes, all this level, which are not in visited. Okay, cool. So let's make our visited initially. Okay, root will be always unvisited. Yeah, it will be. So if 1 second. So let's make a queue which is equal to root. Now while queue is there, again while queue is there, make yeah, make our current level. Okay, one more thing. If level is equal to 0, return root. If level is equal to 0, then return root. Root in an array form. Okay. Now while q is there, so let's take current level is equal to something like this. See, one more thing is that you can solve this whole question using graph. Okay, just make a graph out of it and you will be able to solve. But that will be a bit trivial, so I didn't go that way. Okay, so let's continue. While q is there, lag. It's like, okay, while q is there, so let's pop our current node q dot pop. Okay, and pop 0 from left because it is a queue. Now if node dot left, then q ue dot not q, append it into current level dot append node dot left. Okay, and yeah, if node dot right and current level dot append node dot right. Okay, left and node dot right. Now what? So now q is ended. So we are gonna, if we are gonna say q is equal to current level now. Okay, and here what we have to do is we have to decrease our level from the one we have. Okay, and if level is equal to, okay, 1 second, if level is equal to 0 at any point of time, then return this current level. Okay, but we have, see, one more thing, we haven't taken care of widgeted part. So when we are at root, okay, initially we are at root. So if node dot, yeah, here we have to say if node dot left not in widgeted and node dot left, and we have to do the same with node dot right too. If node dot right, yeah, if node dot right not in visited and current level dot append not node dot left, and every time visited will only contain the parent. Okay, because yeah, visited should always contain the parent. Go anywhere, if we are starting from this, if we know that this is already there, okay, instead what we can do is we can directly call, okay, no, it is correct. So we have to go to left and right and we will check whether it is in visited or not. If any of it is in visited, we won't go further. So yeah, and visited will start with target. Like, see, this visited initially target because we have already visited our target. Okay, initially visited is target. Like set of target. Okay. Now let's see, if level is equal to 0, then return current level. Else return nothing. Yeah, okay, it's fine. It should work. We will debug if there will be any problem. And yeah. Oh, okay. And current level. So this should be appended here. So let's will be node dot right and not, if node dot right not invested and node dot right. Okay. Cool. So this is our BFS. Now we are going to recursively call BFS on all our parent global. So let's remove it. So okay, let's, yeah, visited is equal to set of target. Now what? So for I in parent global. Okay. So we have to traverse in reverse order. Okay, because it will contain, yeah. So for I in parent global, we are going to traverse it in recursive manner, like in reverse order. So for I in parent global of -1. Okay. Let's append parent global dot append target. Yeah, this will be better. Now after reversing it, like parent global dot reverse, let's reverse it. So now we have, so after reversing it, Okay, before reversing it, we have to append. Okay, no. After reversing it, the root node will become our first node. So we are gonna reverse it. Okay. So after reversing it, we are gonna append our target. No, before it we have to do, because if parent global is null, then we will be in problem. So parent global dot is equal to target plus parent global. It will work. So this is our now current parent global, and we reversed it. Okay, do we need to reverse it? No, we don't need to reverse it at all. One second. No, the first one is root node, I think. Reversed, we have to do like this. Reversed parent global. Now we can travel it easily. So for instead of node, yeah, for path node rather. For path node in parent global, do a BFS like k result is equal to empty. Now result is equal to do a what? Do a BFS. Okay. BFS on path node. Okay. Path node initial and pass the widgeted. Okay, widgeted and level is already there. So widgeted and initially nothing is widgeted. Okay, nothing is widgeted. Result instead of this result plus equal to and widgeted dot add path node. Let's check our result for I in res print I dot val. Reverse, okay, reversed. Let's remove all this printing for now. I'm printing a lot of things. Okay, now let's so df. Okay, one second. Concatenate list. One second. So let's. The first one is target now. Why am I reversing it again? Sorry. I better let's reverse it at first. And I don't know why the error is there, but okay. Let's reverse it. Then concatenate it. Target can be null. Visited is not defined. Oh, I removed visited, I guess. Okay. Visited equals set. Res print I dot val type error. The level is not there. So level should be 0. Oh no, sorry. So every time, let's check our count. Okay, count is initially k. We have to take kth level or 0th level. Yeah, so we have to take kth level every time. Initially it is k for the first, and after that k. Okay, not k, instead count. So k is given. Now every time we are gonna decrease our count. Yeah. So if Okay, yeah, we decreased our count. So at any point, if count is less than 0, then return nothing. Okay. If level is less than 0, return root. If level is less than 0, return nothing. And an empty array. Out of the, because we can't traverse it now, it is negative. Okay, it is returning, I guess. Yeah, it is returning and none. So instead we have to return, yeah, here, let's return an empty array. This should work fine. Yeah. So yeah, 7 and 5 is printed. We we got the solution. Okay. So let's return res. But the thing is whether it will work for everything or not. So let's comment it out. And there are more things to comment out. Okay, okay, and print. Okay, this return res. And if what if count is equal to 0? Yeah, it is returning root. So no problem. Okay. Output is 7562. Um, okay, we will check it. So before that, yeah, 36 minutes. But it is printing 75. 562 null 74. Why these all are there? So 3562 null 7. Why? 1 second. So current level I'm always making it null, and if level is equal to 0, I'm just returning current level. 1 second. So let's do this again. For I in res, what we have to return is, yes, it is printing only 7 and 5. It is good. 7 and 5 is our answer. Okay, we have to return list of integer. Okay, so return res.val for I in res. Let's see. List has, sorry, I.val. Let's write it like node.val. Let's see now. Okay, let's submit it directly. I'm not gonna check it on any test case. If it won't work, okay, go on. Yeah, it worked. Okay, thank you guys. Subscribe for more questions. Subscribe and like the videos for more questions if you like it. And meet you soon. Thank you. Bye.